Okay, so in this question, this is one of the experiments we've watched in class, and we've got this hydrocarbon burning in the apparatus. It says the funnel becomes hot, the colourless solution forms in tube A, and the indicator changes colour to show an acidic gas. So explain these observations. Okay, let's do, first of all, the funnel gets hot. So why does the funnel get hot? Funnel is hot as the burning is exothermic and releases energy. Number two, why do we get this colourless liquid formed here? So what we've got here, this is a hydrocarbon. Hydrocarbons, when they burn, one of the products is water. The water as a vapour will rise up here, come into here, and in the ice it will condense. So what's forming in the colourless liquid is water is formed as it condenses in the tube A. So water forms it condenses in tube A. And then the last little one, why does this indicator show there's acidic gases? So this is step number 3. Why does it show acidic gases? Well, the gases that are going to be produced, the fact this is impure hydrocarbon also means it contains sulfur. So what we will have here is that sulfur dioxide and carbon dioxide are produced. These are acidic gases, and that's why it changes colour. 3 marks, 1 mark for each line in the response. Okay, energy calculations. So methane burns as shown. Calculate the energy change for this reaction. So the best way of doing this is we're going to do a before and after approach. So before, we've got 1, 2, 3, 4. We're going to break 4 times carbon-hydrogen bonds. And then we're going to break 1, 2 lots of the double bonds for oxygen. Afterwards, we're going to make 2 lots of C double bonded to O. And we're also going to make 1, 2, 3, 4 lots of OH bonds. Use the table now, put the numbers in. So if we go up here to carbon-hydrogen is worth 435. So times 435. And this is 2 lots of this double bond oxygen is 496. 2 lots of 496. This side, we have got 2 lots of carbon oxygen double bonds, so that's 805. So I've got 2 lots of 805. And I've got 4 lots of OH bonds, which is 4, 6, 3. And we've got 4 of those. So I'm going to plug those numbers into my calculator. Remember, before here, I should probably add here that these are bonds broken. And here we have got bonds being made. Okay, so let's work these out. So we've got 4 times 435, and that's going to equal 1,740. 2 times 496 is 992. Add those together to get a total. That is 2732. On this side, do exactly the same. So I've got 805 times by 2 is 1610. And then I've got 4 lots of 463, which is 1852. Add these together, so plus 1610, and that's going to give me 3462. Okay, and then all I've got to do to work out the change is take the energy for the bonds being broken, and subtract the bonds being made. So you've got 3, 4, 6, 2. Plug that into my calculator. Subtract 3, 4, 6, 2. And that's going to give me an answer of minus 730 kilojoules per mole as a final answer. There are 4 marks available here, so it's quite a big calculation to do. You are going to get, in terms of marks, 1 mark for working this part out correctly, 1 mark for working this bit, 1 mark for doing that, and then 1 mark for your final answer. Okay, final question in this one. This is a 6 marker, and again they give me a lot of information and a table full of data, so you have to use this data in order to get your answer and the marks you need. And it wants us to discuss and compare the impact on the environment, that's really important, impact on the environment, from these different engines shown here. Let's just look at the engines. So I've actually got 2 that are using petrol, but one of these has got a catalytic converter. So one comparison I want to make is petrol against petrol, but with a catalytic converter. And then the second thing I want to compare is how does petrol compare with diesel. So I'm actually going to compare, to make it a fair comparison, petrol with no catalytic converter against diesel. So my second comparison is petrol against diesel. That's my second comparison. So what I'm going to do is first, I'm going to explain what are the environmental concerns with these gases. So firstly, environmentally, carbon monoxide is toxic. It will bind to red blood cells and it prevents them from carrying oxygen, so that people will suffocate. Nitrogen oxides, remember that means nitrogen monoxide and nitrogen dioxide. These cause acid rain. This leads to damage to buildings and statues. It also can kill plants and trees, and it can also produce, in warm climates, a photochemical smog, which can lead to breathing difficulties in people. Carbon dioxide is a greenhouse gas. This means it's linked to the cause of global warming, and global warming, the impact of that on the environment is you get sea levels rising because the ice caps begin to melt. Next little bit, carbon particulates. So carbon particulates cause breathing difficulties in people. So that's something that, again, environmentally is an issue. Now let's look at my 2 comparisons. So petrol versus diesel. If you look at the data, petrol has got more carbon monoxide and also more carbon dioxide being released. The petrol has less nitrogen oxides and also less particles being released. The second comparison was the impact of a catalytic converter. So here I'm comparing petrol against the petrol with a catalytic converter. As you can see, we're going to get less carbon monoxide, and the data also shows we get less nitrogen oxides. Overall then, what does it look like? Well, overall, petrol engines with a catalytic converter produce less carbon monoxide and less nitrogen oxides. Diesel overall makes less carbon monoxide and carbon dioxide, but diesel does produce more nitrogen oxides and particulates. I've counted up the bullet points. There are 19 bullet points, so if you can award yourself marks in this way, so if you've got 17 or more, get 6 marks and continue working that way to give yourself a total marks for that 6 marker.